All right. This week we're going to start talking about polynomials. Polynomial is an expression which has many terms. We've already looked at some of them, such as an equation, a linear equation in two variables, 7x plus 3y equals 1, or just the expression 2x minus 3y minus 1, etc. In general, a polynomial would look something like this: negative 49x cubed plus 806x squared plus 377x plus 25. The terms of these polynomials are each of the things that are separated by a plus or a minus sign. So for example, the first term is said to have a degree of 3 because the power of x is 3. The second term has a degree of 2, the third a degree of 1, and the last a degree of 0. The highest power, which in this case is 3, is called the degree of the polynomial itself. So this would be an example of a degree 3 polynomial. And the first term, which corresponds to the highest power, is called the leading term. And the constant attached to the leading term is called the leading coefficient. For example, 7x squared minus 2x cubed plus x plus 7. First, you have to arrange them in decreasing powers of x, which makes it very obvious and clear to find the degree, which is 3, the leading term, which is negative 2x cubed, and the leading coefficient, which is negative 2. Now, you could have a case with more than one variable. For example, 8x to the 4y5 minus 7x cubed y squared minus x squared y minus 5x plus 11. In this case, you add the power of all the variables, x and y. So 4 plus 5, 9, which is the highest. You can check. It's going to be the degree of the polynomial. The leading term is going to be 8x to the 4, y to the 5, and the leading coefficient is 8. As a function, if you write f of x equals, say, 2x squared minus x minus 1, then this is called a polynomial function. For example, you can find f of 0, f of 2, etc. You can try this out. This is similar to evaluating functions, which we have already seen before. Now let's look at operations on polynomial functions. Addition, subtraction, you collect the like terms. So the 2x cubed and the 2x cubed gives a 4x cubed. Negative 7x squared, positive 7x squared gives a 0x squared. And so on. So only like terms, which means with the same variable, the variable with the same power attached to it can be combined. This is very important. Polynomial graphs and end behavior. We already know what a degree 1 polynomial looks like. It's a straight line. Polynomials of higher degrees are also smooth and continuous, but they look like curves. Degree 2 generally looks like a parabola opening upwards or downwards, and then the other graphs represent degree 3, they could be degree 5, etc. Now, how do we define end behavior? Basically, we answered these questions. What happens to the function as x becomes large, or as x approaches infinity? In terms of graph, what we are saying is, where does the graph go, or where does the output go as you move the input in the right direction? So for example, in this graph, the first one, as x goes to infinity, y goes to positive infinity, or f of x goes to positive infinity. Whereas in the second graph, as x goes to infinity, f of x goes to negative infinity because it's going downward. The second question to answer is, what happens to f of x as x approaches negative infinity, or a really small number, small in the negative sense. In the first example here, as x goes to negative infinity, f of x also goes to negative infinity because it's going down. And in the second example, as x goes to negative infinity, f of x goes to infinity because it's going up. In essence, the question of end behavior is asking what happens to the output if the input approaches positive infinity and negative infinity. For a polynomial function, we will see that this depends only on the leading term. We can develop an intuition by looking at some examples. Let's say f of x equals x cubed plus 3x squared minus x minus 3. Leading term is x cubed. So as x goes to positive infinity, x cubed also goes to positive infinity. You can verify that. When x is 1, x cubed is 1. When x is 10, x cubed is 1000. When x is 2, x cubed is, this should be 8. When x is 100, x cubed is 100, 6 zeros, etc. Similarly, as x goes to a negative infinity, a large negative number, x cubed also goes to negative infinity. Let's look at another example. Comparing in the first example, in this one, what I have is that the coefficient of the leading term is negative. So I have negative 2x squared. In this case, when x goes to positive infinity, the negative x cubed goes to negative infinity. And as x goes to negative infinity, x cubed goes to positive infinity. That's because um, if you take this negative infinity here, the cube is going to be negative, and then you have a negative in front, the negative and the negative becomes a positive. Similarly, if you take this particular example, the leading term is x to the 4, something different happens here. What happens is as x goes to infinity, f of x also goes to infinity, and as x goes to negative infinity, f of x still goes to infinity. Why? Because you're taking a power of 4, so even if it's a negative number, when you multiply it with itself 4 times, it becomes positive. So we can basically combine this and say that it depends on whether the leading term is positive or negative, and whether the degree is odd or even, as illustrated in the above examples. And the pattern can be summarized as follows. Leading term positive, if it's odd, the end behavior is similar to, the output behaves similar to the input. If the degree is even, the output is always positive infinity. Leading term negative, for odd degree, the output behaves exactly the opposite. So when input goes to infinity, output goes to negative infinity. When input goes to negative infinity, output goes to infinity. And when it's even, the output is always positive, negative infinity in this case, and negative infinity in the second case. So in general, what you can say is that if the degree is odd, the behavior for x going to infinity and negative infinity will be opposite. Meaning if it goes up on the right side, it's going to go down on the left. And if it goes up on the left side, it's going to go down on the right side. And for even degree, the behavior will be the same. So it's always going up on both sides or going down on both sides. That's it for the first video.